Is f of x continuous? Oh, I'm sorry. If f of x is continuous with values in the table below, does the function equal 3 at some value c? If so, why? So we have some points here, and if you need to, you can always graph them, which I am going to go ahead and just do. So I've got -2, -3, 1, 2, 4, 1, and 7, 4. Okay. And I know that my function is continuous, which means it's not going to go like here and then like do something like this. It's not going to have vertical asymptotes or any holes. So it's going to do something like this. Who knows? Like, it might go up to infinity. It might go back down. It doesn't matter. I have these 3 points. There also might be, I'm connecting them, but like you could connect them this way. That's still continuous. It could be like, whoa. It doesn't matter. We don't know what happens. All we know is that it crosses these 4 points. The question is, does it have a value equal to 3 somewhere? So is it for sure going to cross that line? Is it going to cross the line y equals 3? So is there any way for me to draw it where it doesn't? Well, there is a way for me to draw it where it doesn't, where I go like this, right? But wait, that's not continuous. So is there a way for me to draw this function without lifting my pencil and not crossing that line? No. It has to cross y equals 3 at least once. Again, it could like cross it a couple times. There could like be other stuff that goes on, but at least it crosses it once. And it has to cross it once about here. And I can't say for sure where that happens. I can't say it happens at x equals 6 or x equals 5. But I know because I have a y value of 1 here and a y value of 4 here, that all the values between 1 and 4 must be crossed because f of x is continuous. And that is called the intermediate value theorem. So, yes, the function is continuous. So, by the intermediate value theorem, over the interval, so let's look at our interval here, from 4 to 7, there must exist all y values from or on 1, which is less than or equal to y, which is less than or equal to 4. So I'm mixing 2 notations. It's not amazing, but that's what I'm trying to say for the intermediate value theorem. So I think it's still pretty clear, even though I did use interval and inequality notation. So because the function is continuous, and you always have to start with the function is continuous. So if you're using the intermediate value theorem, you have to state that you know the function is continuous. Because the function is continuous, the intermediate value theorem applies. The intermediate value theorem says that between any 2 x values, you must have all the y values between them. So because we must have all the y values between 1 and 4, that includes 3, then there must be a location between x equals 4 and x equals 7 where we have that y value of 3. It has to happen somewhere. I don't know if it's 4.2. I don't know if it's 6.9999. I don't know. But I know that there must be some location where the y value is between 1 and 4. All the y values between 1 and 4 exist on that interval. So again, make sure you start with the fact that you know the function is continuous, state the theorem, and then state your intervals and be really clear. Like over the interval, there must exist all y values from 1 to 4.